first things first, who is this handsome young man you see before you? Thank you for asking. My name's Stephen. I'm a machine learning scientist here at Bumble, working mostly on computer vision and NLP models, so any questions you may have about that, please feel free to hit me up. And today, I want to ask you a question. So if I was to show you these 5 tweets, would you be able to pick out some of the main things being talked about here? Now, I'm an optimist. I like to see the best in people, so I think you probably could. It's quite easy, right? We have mentioning sleep, mentioning school, Netflix. It's pretty simple. What about now? Now, again, there's a few more tweets here, but I think for the most part, it's still quite easy, right? You can see some bigger topics starting to come to the front. Things like food, school is mentioned again, the weather is being mentioned, this kind of thing. And like, how high could you go? How many tweets could I show you that you would still be able to do this? And even more difficult, what if they looked like this? Now again, I'm an optimist, but I'm going to make a very bold claim here. You probably can't speak 10 languages. So suddenly this is a problem that humans can't necessarily deal with, especially when you try to go at scale. And this is the core idea behind topic modeling. It's how do we take these large data sets of text and actually figure out what's being done. And especially at Bumble, when we try to tackle this topic modeling, we're dealing with, what, hundreds of millions of users, I don't know, like 70 languages and something. And so generally what's right off the shelf now does not really cater to the scale and the complexity that we have to deal with. So we made BuzzWords. And what is BuzzWords? Well, long story short, it's a multilingual, GPU-powered, BERT-based topic modeling Python library, and that really does not roll off the tongue. So long story long, BuzzWords is this. Now, we took the algorithm from an amazing library called BERT-topic and kind of altered it a little bit so that it would be a bit quicker, right? The original library isn't entirely on GPU, so we decided to use Rapids, which is sort of NVIDIA's suite of data science tools, and sped up the whole process. And the algorithm itself is quite simple. So step 1 is sentence transformers. If you haven't heard of sentence transformers before, you probably should. It's amazing. The text goes in, and there's a suite of pre-trained embedding models that will spit out an embedding for every single text in your data set. And these can be multilingual, they can be monolingual, you can pre-train your own, you can plug in different ones. Whatever you want to do, it can probably do it. The issue is that these embeddings are huge. You're dealing with like 300, 400, 500 dimensions in your embeddings. And when you try to apply that to more complex computations, it's a serious bottleneck, right? It just slows things down far too quickly. And this is where UMAP comes in. So UMAP is a dimensionality reduction algorithm, which can take these massive embeddings and shrink them right down while still maintaining a lot of the meaning behind the original sentences. So suddenly your 500 dimension embeddings are down to like 5 or 10. And this is where you can do clustering. So HDBScan and UMAP, they work very, very well together. HDBScan is this clustering algorithm which takes these smaller embeddings and sorts them into topics or clusters of embeddings with similar meanings. So in the example from earlier, these 2 first ones about football, HDBScan would understand the meaning from the shrunk embedding and realize that they're quite close together, and suddenly you have a topic about football. But how do you know it's about football? And that's where the keyword extraction comes in. So we use a library called KeyBERT, which is actually made by the same guy who made BERT-topic. And we sort of treat every topic like one big article. So we put every single sentence from these topics together and essentially say, hey, KeyBERT, pull out the keywords, what is this about? And then in the end, this is what you end up with. An end-to-end pipeline wherein your raw, unlabeled data goes in, and out comes all of these topics where you can actually understand what these topics are about because they all have keywords associated with them. It also has outlier detection. So topics that may, or sentences that may not fall under any other topic, they're sort of brushed away. And it means that you're not ending up with inflated topics because they're trying to force them into different ones. But then the question is, how do we actually deploy it? And it's quite simple. We have 3 main ways that we do it here at Bumble. And all of them come from this one base Docker image. Now, of course, BuzzWords, with all of the different algorithms and dependencies, it's a little bit complicated to install. So we just do all that for our data scientists, for our machine learning scientists, and just throw it into a Docker base image. From there, this then feeds into the 3 main ways that we use it. Step 1 is the classic and inference API. So we train a model, we have the topics, we're happy with it, it's all clean. And then we deploy it on Kserve so that other parts of the company can then benefit from the insights that we've already gained. The second one is Kubeflow pipelines. Now, this is more about like scheduled jobs. And the beauty of this is that there's 2 ways that you can actually use this. So one of them is for pre-trained models, just like with the Kserve API. So we train a model, we're happy with the results, and then we throw predictions in it through batch processing. But then you can also train new models on a schedule. So the input data comes in, we train, and then all the insights come out straight from there. And so there's a lot of flexibility that these Kubeflow pipelines allow us to do. And we can do it daily, we can do it weekly, we can do it with different parameters. It's really, really useful. But it's not as flexible as we always need. Every now and again, we'll get a stakeholder coming to us with, hey, I have this survey with text data. Hey, I want to know what the problem with these users is, this kind of thing. And this is where we sort of use our Jupyter notebooks. This is more dealing with the actual API of BuzzWords itself and training models through there, getting insights directly from the outputs. And this is how we kind of deal with it for ad hoc analyses. So just a once-off, people come in, there's a problem, how do we fix it? And the best thing is that this is not just limited to Bumble. We have actually open sourced BuzzWords entirely. So please do take a look, download it, try it, break it, complain about it, all those great things that we do here. We would be honored if you guys tried it. With that, I thank you all for your time. I thank you for having me. If you'd like to see the repo, do scan the QR code. And I think we have time for questions. I don't know. Yeah? OK. Yeah.
How did you do your validation? You like reduced it down to some like topics. Was it manual? Was it some human looking at it, or was it automated? Like, and how did you do any monitoring? Do you have any monitoring around your models?
Yeah. So for anyone who couldn't hear it, the question was about validation and how do we sort of monitor the quality of models. A lot of it is very hand-wavy. Topic modeling by design is not particularly accurate. And so a lot of it is kind of a mix of, for example, are there too many outliers in this? Is there one topic that's completely taking over? Are the embeddings of these topics too close together? Like, what is the split on this? So these are sort of the ways that we can automate it. But then we do also need a little bit of human intervention, because if you have a data set with a massive amount of people saying hi, or just like random words like that, these will actually be major topics from this. And so often you do need that kind of human touch to go in and say, OK, no, like this topic is useless. Let's push it to outliers. This is where the pre-trained models come in versus just training a model and getting the outputs. That's how we sort of curate the more higher quality models with a mix of automated and human. I hope that answers your question. Yeah?
I have a question about what are the use cases of this model and how does it contribute to the user experience in Bumble?
Yeah, so the question was sort of about use cases and how it contributes to the user experience actually at Bumble. And most of the use cases that we have are internal. Because I said earlier, topic modeling is a bit hand-wavy, it is quite difficult to push it out into any user-facing feature. But for the most part, it would be internal. So I guess like the obvious example is surveys. We send out a survey to our users asking about something, and they have a box to fill in feedback. Now, if you get 200,000 survey responses, you're not going to have people looking through all of these to figure out what's happening, especially so if you do it across multiple countries. And so what we can do at BuzzWords is, because it's so fast, even if you have a survey with 200,000 responses, you can get insights in like 2 or 3 minutes with BuzzWords. And so that's kind of the idea, is like to point people in the right direction of like, this is what people are sort of talking about. These are like the most important things. And then you kind of take it from there.
Can I ask one follow-up?
Yeah, of course.
Have you, when
So yeah, the question was, have we thought about using it for like building user personas and that kind of thing? We have thought about it. We've sort of we've like looked into it, but we haven't really done anything concrete on it. That's something that we might spend more time on, but I don't have the full answer to that one, I'm afraid.
Maybe say one more, Stephen.
Yeah. So one more question. Yeah, yourself.
Are you investigating things like counterfactuals within your NLP model? Say, for example, like you're looking at semantic text, right? So are you investigating is the equivalent of not football? And separately, how are you sort of investigating biases within your model?
So this is actually one of the reasons why, the question was how do we deal with counterfactuals? So the example is if one person says I hate football and one person says I love football, these would be thrown into the same topic. And it kind of harks back to your question of building user personas where we would have to distinguish between that, right? We don't really do, so like the most that we realistically can do is appending another model on top of the results, right? If we append like a sentiment analysis model, then that kind of, or an emotion detection model, that's sort of like the most that we can really do. Because at the end of the day, like we want to play to the strengths of topic modeling. It spots the topic, and then we would do everything downstream from there. And yeah, I hope that's